I'm going to do here another example of how to find the domain function. Here again, it's an example of roots with factors inside here. Here we have this root which has inside x squared minus x minus 5 minus 6. We just have to start out by factoring out what's inside the root here. So that's what actually I'm going to do here. I'm going to factor out that. Here would be x minus 3 times x plus 2, and that will be the factorization here. Just going to close here the parenthesis here. Now, after that, we have to make sure that what's inside the root, these two guys inside here, they have to be greater or equal than 0. So I'm going to write the factors just like they are here, multiplying x minus 3 times x plus 2. It has to be greater or equal than 0. Now from here, I'm just going to repeat pretty much the process from the previous video, so I'm going to do it a bit quicker. Feel free to re-watch the other one or stop this at any time. So pretty much I'm going to pick each factors. I'm going to equalize to 0, both of them. X minus 3 will equal to 0, x plus 2 equal to 0. So here I'm going to get x equal to 3, and here x equal to negative 2. Now I have to place these two values for x in my nice line I have here on the right. So I'm going to place here, let's say, here the negative 2, and I'm going to place here positive 3. So now what I'm going to do here, I have to pick a value for it falls into this interval from negative infinite to until negative 2, and I have to pick another value in between negative 2 and positive 3. Again, a value from positive 2 to infinite. So I'm just going to pick the simplest possible values. I'm going to pick here x equal to 0. I'm sorry, here it's x equal to negative 10 here. Now here I'm going to pick, let's say, x equal to 0, and here I'm going to pick x equal to 10 here. Now I have to substitute these values in the actual expression here. I'm going to do it. I have to substitute in the inequality here. Make sure they pass or not the test, the greater or equal test. I'm actually going to to copy this like this, just in order to reuse it in here and here, and I think that would suffice. I'm going to place here I have my minus 3 plus 2 minus 3 plus 2 minus 3 plus 2. Okay, now I'm going to substitute the values of x, this and this one, in every case here. Here will be negative 10 minus 3 times the negative 10 plus 2. Here negative 10 minus 3 would be negative 13, and here we have a negative 8. Now here we have to be concerned only again with the signs. The only thing that matters here would be a negative times a negative, and we have to ask, is this greater or equal than 0? Well, actually, yes it is. It will be a positive number here in the result. So we include this interval, all of it here, color this out. Now I'm going to do here the same for the second value of x, which is the 0. Here I'm going to place 0 and 0, so this will be a negative 3 times 2 greater or equal than 0. Here we have to be concerned again only with the signs, a positive, a negative, positive, greater or equal than 0. Now we have to ask ourselves, a negative times a positive, will it be greater or equal than 0? No, it will not, because these two guys multiplied will always have a negative result. So they will fall, if you place it in here inside the root, you will have a negative root inside. So okay, let's continue. So in other words, we will not color out this interval here. Now I'm going to continue with the last value for x, which is x equal to 10. I'm going to place it in here and here. So this would be a 7 times 12 greater or equal than 0. Again, we just have to be concerned with the signs. This is a positive, this is a positive, this is greater or equal than 0. Well, we have to ask ourselves, well, actually always positive times a positive number will always be above 0. So this passes, these two guys passes the test. So we include this interval here. And we color this out. Now here, it would be just, I won't be testing the -2 and the 3, because I think you should notice by now that if you place the -2 in here in the statement, you substitute it here, you will get a 0 here in the second factor. So if you substitute a negative 2, let's say like this, x equal to -2 and x equal to 3, in any case you will fall into this, and 0 is great. Is it 0 greater or equal than 0? Well, actually yes, in both cases here. So that's why we include the -2 and the 3 on the result. That is to say, we color out the -2 and we include as well +3. We're coloring out, and now the only thing left would be just to write the solution for the domain of this f of x. Would be, I'm going to write it here down on the left, would be the domain of f, and now we have pretty much just to read what's in the graph here. We're going to include all this. That would be from -infinite until -2. We include the -2 just by this test we talk about here. Now would be union. We include from +3 to infinite, +3 to infinite. We close here this parenthesis, and we are basically done here.